Thank you, Karen. And thank you all for coming. And before I even start, I'm going to ask you to put some things in the chat right away. But in general, please don't wait till the end till you put something in the chat. And if Karen happens to see it and I don't, she'll unmute and interrupt me. You can unmute and interrupt me verbally if you like, or you can put questions or concerns or something you wanted to know about, like how would I make this work with these kids that I have that are have unique characteristics in some way or something. Don't wait to the end. And I'd like to cover everything you're interested in. So if you want to hear more about this or that topic, please don't wait to the end. So we're going to talk about patterning today, um, patterning in mathematics, and taking it into algebraic thinking, or at least pre-algebraic thinking, depending on the age and the developmental level of the kid. But to warm up, I'd like to ask you to put something in the chat, and we're going to do on these. We can just do put it in the chat and hit return. So I will try to follow it. I'll try to keep a long window up for the chat and everything. Just tell me the next 3 to 6 numbers that you would put in a sequence that started 1, 2, 4. Go ahead. Oh, hello everybody who put hi in the chat. Hi. Thanks for introducing yourself. What would be the next 3, 6 numbers or so of that one? Thanks, Christina, Marisa. Ooh, some very different ones here. Ah, very nice. Ah, subtly different. This is really interesting. Oh, okay. Keep going if you haven't put anything in, but it's going to scroll right outside my window. So, Christina, why did you say 8, 16, 32? If you don't mind unmuting. You could just pass on that if you're a
Sure.
little
No,
shy.
I started doubling. So 1 plus 1 is 2, 2 plus 2 is 4, and then so on and so on.
Yeah, then how could it be, Marissa, that you have 7, 11, 16? If that doubling makes so much sense? What were you thinking?
I was thinking 1 plus 1 is 2, 2 plus, and 1 plus 1 is 2, 2 plus 2 is 4, 4 plus 3 is 7, 7 plus 4 is
Ah,
11.
very nice. You had to add 1, then you added 2, then you added 3. So perfect pattern. Very nice. Let's see, Rebecca and several others had the doubling. Karen, you and Mary had almost the same thing, but you differed on the last number. So go ahead, you two, tell us what you were thinking, one of you. Karen, if you don't know who goes first, how about Karen? Karen might be deep in thought or having trouble with the microphone. Mary, can you explain why you got 5, 6, 8? Do people? I'm hoping people know how to unmute. Go to the controls there and unmute yourself. It works so well for the beginning people, but
Karen typed hers in the chat.
Karen, the chat's so long I didn't even see it there. Sorry about that. I made a mistake. I wanted to put an 8. Okay. Very good, but I bet somebody could come up with a justification for the pattern you did put in there. Anybody unmute and tell me how you got what you were thinking about. Connie says the same as Amira. Repeat what you did. Okay, very good. There's still some different ones. 5, 5, 7, 8. All right. Anyway, let's move on. This is interesting for a lot of reasons, and I'll get back to it, as I go through those reasons. A learning trajectory is an approach to teaching and learning and a way of thinking that's grounded in kids' natural development. So we have a goal that standards often give us, or the like. and it might be a goal for a district. It could be a Common Core goal or anything like that, a state goal. But the mathematics of it is generally broader than any statement of a goal, and especially in patterning, that's true. And I'll get back to that. So this tool, this approach to teaching and learning that's based on following the natural development and thinking of kids, patterns of thinking, if you will, right, has three parts. There's a goal, there's the developmental progression of levels of thinking, and then there's instructional activities and teaching strategies that help kids at this level get to the next, and they get at that next level, get to yet another sophisticated one. But the goal is really interesting because what's a pattern? What isn't a pattern? You know, there's patterns in our clothes. There's a pattern that if you could buy, if you remember this, anybody still makes dresses, you can buy a pattern for a dress and you cut it out, but it's not a repeating pattern. Well, it kind of is, because everybody who uses that would make the same thing. So it's what we call an AAAA pattern in a way. But in mathematics, it really gets complex, yet overwhelmingly important. So Lynn Steen is a mathematician who once defined all of mathematics as the study of patterns in number and space. So he didn't just say it's the study of numbers and the study of space and geometry. He said it's the study of patterns in number and space that is the true mathematics. So there's many types of patterns. And a lot of people nowadays in early childhood are really talking about patterns and structure. They like thinking about those at the same time. But many of the ideas we have of patterns, you know, are not mathematically defined. So we have to be thoughtful and careful about it, right? And so we do patterning, and we do it intuitively with kids before we actually talk about patterns with them. For instance, we count in patterns. So we'll kind of go 1, 2, 3, 3, 2, 1. You know, or we'll count in patterns similarly to that. Let me do it a little different way, where I'll stamp around the classroom with my preschool or kindergarten kids and go 1, 2, 3, 4, 5, 6. So they're learning the counting sequence. That's one main thing. They're also learning one-to-one correspondence if we stamp in time with the counting. But they're also hearing louder, softer, louder, softer. And I think the way I was doing it, the even numbers were louder and the odd numbers were softer. And people, even though there's kindergarten and preschool, such activities do form a kind of mental pattern for them that they get used to differentiating between even and odd. So you can do so much with it. Today, we're going to mostly emphasize repeating patterns and then move forward to early algebraic thinking. Common Core slipped away from me a little bit there. The Common Core, people often criticize it as where is patterns? If patterns are so important, where is it? So the reason, one reason, that mathematicians didn't want to put, when they were commenting on the Common Core, they didn't want to put like patterning like red, blue into the Common Core, because this is what often happens in early childhood classrooms. Now, this is a kind of fun activity you could do with kids, but I'm not, the cubes I've put in this here are not what I would use with kids. But just work with me here and I'll try to make the point more clear. So if I pull this out, so the cube tower I have in here, you see, I hope, a red, and then an orange, and then a red. And so a lot of times in classrooms, mathematicians who went in classrooms, not many do, but some, would see the teacher say, what comes next? So I'm sure you can guess what often happens is the kids will say orange, you know? But the mathematician is thinking, Does it have to be orange? No. I put a red there, and then an orange, and then another red, and you got to be thinking, wait a minute, this doesn't make any sense. Another orange, another red, and then this is a pattern, incidentally, I would not suggest starting patterning with kids with. It's a really confusing pattern called ABA, ABA, ABA. But a mathematician will say, unless you've defined the pattern as ABA, the next one could be black. And the entire pattern could be, I got to hold it horizontally for the screen, could be ABA, 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 C, ABA, and so forth and so forth. I didn't have enough red cubes to actually continue it for another unit of the pattern. So the point here, you might be wondering if I have one, is mathematicians would see teachers just showing a little bit of a pattern and saying, what comes next? And they said that you haven't defined the pattern yet. Anything could come next. The black could come next, and then a green could come, because you're just inducing kind of from a simple thing, but it's not mathematically defined. So we'll get back to that when we talk about the unit. But there's two things I wanted to say. Why is patterning not in there as a topical area? And second, that patterning is in there as the more general and powerful idea of patterning. That's in Common Core Standards for Practice 7 and 8. Look for and make use of structure in math, patterns in number and space, and look for and express regularity in repeated reasoning. So as long as we do it mathematically, they're really happy with that. Similarly, I was lucky enough to be on the National Research Council report on early mathematics, and they said the same thing. Pattern's a process. Pattern and structure is a process. They also said some kids enter school with far less knowledge, and that's an opportunity gap. And so we have a real responsibility to use the thinking of kids, learning trajectories. They didn't like the term learning trajectories, my colleagues who wrote this book with me, so they call them learning paths. Same thing, for both excellence and equity, because kids who have less experience with these things will learn it faster. And it's so important to get these kind of ideas of the process of patterning down for kids. So in our report, we say, looking for patterns and structure and organizing information are crucial mathematical processes. Pattern content usually focuses in the early years on repeated reasoning, and that's appropriate, but the specific skills in these examples are but a small part of the role these processes play in mathematics. So could you put in the chat, and I got to scroll down to the bottom of the chat here, is, thanks. Karen's got some hints in there if you can't see. Julie, I'm so sorry. Julie, can you see now? Can you put it in the chat, Julie, if you now can see me, if you fix that? She said she couldn't see, so I just want to hold this up, at least for her and anybody else that couldn't see, that this is indeed a red, orange, red, red, orange, red, red, orange, red, black. And it's not a pattern yet because I didn't have enough reds to keep it going. But that was the unit of the pattern I had in mind. There's Julie. Yes, okay, super, Julie. So think about this just to yourself. You don't have to put these in the chat. What questions do you usually ask kids if you give them a pattern? Like a more quote-unquote normal pattern that we often give kids is much easier to see. It's a A-B pattern, A-B, 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 etc., etc., etc. So very often, your thinking could be completely different than mine, but what I often think is people say what I said when I introduced this particular unit connecting cubes thing, which is they say, red, orange, red, orange, what comes next? There's limitations on that. It's not wrong. It's just that we can do it better. And I'll get to that later on too. So first, that's the goal. This general process of patterning, part of which is certainly developed by the repeated patterns and the numerical patterns that we did with 1, 2, 4, and that we'll do at the end when we get through with repeated patterns and go on to other kind of patterns. What is the developmental progression? What are these levels of thinking? Where do kids start and where do they go? And listen, people, you don't have to take notes on this or write it down or try to remember it, because we have a website, learningtrajectories.org, that has all this information in it. And I'll try to show you a little more about that during the presentation and then live if any of you have questions about the website per se.
We're gonna do a pattern.
Okay.
Do you know what a pattern is?
Yellow, red, yellow, red, yellow, red, orange, yellow, red, orange, yellow, yellow, red, orange, yellow.
Interesting. So that's what a pattern is?
Mhm.
Can you tell me any more about a pattern?
Blue, orange, yellow, red, orange, green, orange, yellow, blue, green, orange, pink, and blue, orange, green, yellow, and red.
Okay.
And red too.
Let's make one, okay? I'm gonna make one.
You can't see the yellow if you're like me, if your screen's like me. She's actually making an A-B pattern there, but the video kind of washes out. See, it starts with yellow and then goes blue, okay?
Yellow, blue, yellow, blue, yellow, blue.
Good. Can you put what comes here? Very good. Okay.
Okay. I would love it if you guys don't mind unmuting and just interrupting me and saying what you want to say about it. When I first watched this video, I thought when she had an idea, an intuition about patterns, but she was, yellow, blue, red, blue, pink, so she didn't have an idea that it had to be a consistent kind of thing, but she did indeed repeat 2 colors and then kind of repeat 2 others or add some more in. But when you ask a different question, when she set up a yellow, blue pattern with several of those units showing, she could follow that just fine. So what does she know about pattern? Complex. But she seems to be at an early level, but certainly has some knowledge about it.
So
One more.
It's gonna go like blue,
Red, blue, red.
green. Is it okay if I do green? Okay. And blue, green. Uh-oh. But there are some missing in the middle. What do you think? Which notes do you think are missing? Okay, blue. Blue, green, green.
Oh no.
Uh-oh, do you think there's another one missing? Do you think more blue? Yeah, okay. Here, can we take them off of this paper for a second and try it just on it here. So we'll go blue, green. Uh-oh, let me get you some more colors.
More blues, you mean?
Maybe more blues and more greens, so you have enough to...
Hard to see the colors there. I hope you're following what she's
If it
thinking.
goes, if it goes blue, green, blank, blue, green, uh-oh. What do you think's missing? Blue, green, high five, we did it! Okay, all right, now I'm gonna make a different one.
Now she goes on to make different ones, but I just wanted to comment real quickly that the first girl then was besides making up the colors at first, when she had some put out, she was extending the pattern, right? Keeping the pattern going. this is interesting. The kids can also try to fix a pattern by inserting somewhere they're missing in the middle. Let's see, look a little more, although I don't like the way the colors are hard to discern here.
Purple, green, purple, green. But we want the song to keep going. Can you help me make
Here
the song
she's
keep
just,
going?
she's extending, right. And let's see if we get a different pattern here. Here we go.
No, what is it?
A G pattern.
A, B, C, D pattern. You're right. You made an A, B, C, D pattern. Can you make an A, B, C pattern? Nice. Yeah. There you go. Should we do an A, B, C, D for fun? Okay. There's our A, B, C, D.
Slide.
Okay. So what if we wanted to make the song longer?
Let's go Z.
Let's go see. Can you
But
extend
I
the
afraid
pattern?
we don't have any more.
You don't think we have any more? You want to make an A, B, C, D, E pattern? Is that what you're thinking?
A, B, C, D, E, F.
Oh my gosh.
Oh.
That many? Okay, let's do it. So if we have green, yellow, blue, red, yellow, blue. Would that make a pattern?
A, B, C, D, E, F.
Okay. So can you make the same kind of pattern with the instruments? What would this look like? Look at this one's A, B, C, D. What would E and F be?
E, F.
Hmm.
A, B, C, D, E, F.
Yeah. That was pretty tricky.
1, 2, A. I just guessed it.
Yeah. Do you want to make your own?
Okay, so that just gives you some more. She's trying to try out some ideas we had for teaching patterning and stuff like that. And the girl is clearly smart, but I think there's one thing a little wrong in how she's presenting it, and we'll get back to that later along with the core units. But first, that developmental progression has a lot of levels in it, but let's start out with looking at the forest so we don't lose the forest for the trees. That kids initially understand intuitively, often just an A-B pattern. One thing then the other, day, night, you know, that kind of thing. They recognize them first, but then can pretty well usually fix, duplicate, and extend them at about the same time. We often don't ask them to do those three different things. But duplicate is when you can make the same pattern with the same materials. That girl was actually doing something else to generalize the pattern and see it in color and make it with those pictures of musical instruments. That's a higher level understanding. But all we mean here is duplicate with the same materials, the same pattern. And then they learn to work with other core units. ABC, you heard ABCD and her go crazy going up to E or F. And then similarly, when they get used to those units, they can fix, duplicate, and extend them. Some of those units are a little harder than others, but usually they can catch on. For instance, AAB is a little harder than AABB, you know, that kind of thing. Then, big advance when they understand that every repeating pattern has a core unit and iterates or repeats that core unit. So that's a really important thing for people to understand. And I was not following the chat, so I now see, I ask what comes next and why do they think that? Good. April, can you read the pattern to me? Good. I ask my preschoolers what comes next after saying the pattern. Yeah, I do ask what pattern they make and what they know about the patterns. Connie, what comes next? I ask them what comes next. What do you notice? Always a good question. Karen, thank you. Put learningtrajectories.org in there. We'll return to that later. Hey, the little girl knew the vocabulary pattern. Very nice, Julie. And Connie says she had an idea pattern using colors in a repetitive way. Excellent. Excellent. Thank you. I wish I would have read those before. But good, good, good. It all fits into this. The what comes next is a good place to start. It's not a good place to end. So I hope I can convince you that by the end of this talk. They really want to get into the core unit. And so when we say red, blue, purple, what comes next? The usual answer is red. Nothing wrong with that. But if we can get them to see that the full answer to red, blue, purple, what comes next is red, blue, purple. The next core is what follows. Okay, so we'll talk about that, how to teach it and everything else. And then I mentioned this translation into different materials with the colors to the musical instruments and the like is another thing. And then comes numeric patterning, right? That's like the 1, 2, 4, and many, many myriad others. So what about, how do we teach? Well, when we teach pattern with young kids, and here I'm talking 3s even, but 4s and kindergarten and even first graders if they don't have much experience with it, I gave you the example already of count and move in patterns. And then we do explicit patterning once kids are good at it. So we do dancing patterns. And dancing patterns, units really make sense to kids, you know? Clap, click, kick, kick. Clap, kick, kick. Clap, kick, kick. They're used to it because of the song-like and rhythmic nature of that kind of thing. The core unit, repeating that core unit becomes intuitively meaningful for them, and it just makes sense. So that's a really, I have no idea where that came from. Stringing beads, we also do. And you might string beads in your classroom or other kind of activities like that. But I want to make a suggestion that actually comes from Japan that we adapted. Those teachers noticed that kids often put on a pattern, say again, red, green, blue, green, blue, and then they just throw on, just like that very first girl, when she was asked what a pattern was, they just throw on a black, and then maybe red and blue, but then they put on a yellow, and the math of it kind of floats away. And the activity of making the necklace is what is their major idea of what they're doing. So what do the Japanese teachers do that's so cool? Picture that this is a larger sheet of paper than, of course, is on your screen. But they cut these out on the black lines. Okay, so each one of these is a separate little tag, and this is for a hole punch. And then what they do is you always have to tie a knot at the end of the yarn or string of any kind that you're making the necklace out of, right? So they don't fall off. You put the tag on first. They pick the tag they want, they put it on, and then that serves as a guide for them. So that, for instance, here it's cylinder. This is an AB pattern, as you see. So it's cylinder, sphere, cylinder, sphere, cylinder, sphere, and the accompanying colors, if it, you know, whereas this one, cylinder, cylinder, sphere, cylinder, cylinder, sphere. So do you see that every time they put on a new core, they can always check their tag, and it becomes useful for the teacher who walks over and says, oh, you put a black one on, let's check your pattern here. You know, you did this, 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 and then I should keep with the shape. So cylinder, 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 sphere, and then you put a triangular prism on. So maybe that doesn't fit this pattern, you know. So it really helps. You can verbalize, you can build one unit at a time, and that kind of thing. And the tags, the pattern tags, just help kids keep going with it. Is it Joy? I hope I got your first name right. I have a number of students with vision impairments, so we use sounds and instruments too. Oh, I gotta show you where that teacher that was using the musical instruments, I'll show you why if I can in a little bit, if we have time, Joy. And it is a great fine motor activity, stringing beads. Surprisingly, to me, and I study this stuff, early math, fine motor control predicts later math skills above and beyond things like early math knowledge, number knowledge, and even vocabulary and stuff. Fine motor, very important. So that's a double reason that's important, Joy. All righty. Pattern strips. Okay, so kids can describe a pattern strip. You can help them copy the pattern. You can chant the pattern as you point, and then you say, keep going, and so they make the pattern extend past the pattern strip. And, you know, you can use connecting cubes or other things in there. And as you're doing that, always do the curriculum embedded assessments. The idea of, in your small groups, can they really copy the pattern? In other words, one thing that happens, and I saw that Jacqueline, who was the person who was doing the musical instruments there, one thing she said is, let's put the colors down by the pictures. That I wouldn't have done quite as soon as she did, because then you're just matching, you know, you're just matching this to that, this to that. So I've seen teachers that want kids to duplicate a pattern, but they let them put the red right under the red, the orange right under the orange. Then they're matching colors. You know, hey, if a kid can do nothing but that at the beginning, that's fine. But to see if they're actually duplicating the pattern, put the model somewhere else, and I would have more of this repeating if I wasn't trying to hold it up to a camera, and then have them build the pattern way over here, you know, so that they're not just putting the same color under the color. Some people who have said that kids can duplicate patterns earlier than Julie, my research said we're having them put, you know, a green triangle right under one green triangle, an orange square right under that orange square, and the like. That's not duplicating a pattern. It's really just color matching. So then you can also check, do kids begin to see the core unit? Do they see that there's a sequence of these objects that is the sequence is repeating? That's about it for this slide. What else? Listen and copy. Do rhythmic patterns for sure, right? So this is just completely rhythmic. And then describe it, talk about it. Of course, they join in with you and stuff. And so that teaches so much. It's patterning, but it's also rhythmic subitizing. You know, 2 claps, then 1. Then 2 claps, then 1. And the like. And I would try it, except not at a Zoom probably, right? Our website, Learning and Teaching with Learning Trajectories, has all these kind of patterns in it. And those, if anybody here teaches children with any disabilities, please know that we have certain activities that are marked STEMmy. I'll explain. That stands for STEM, science, technology, engineering, and mathematics, innovation for early education, and and it comes from a whole STEMmy grant that we're in the 7th year of to develop all of STEM, but I'm only talking about mathematics today, for children with disabilities with our friends and colleagues at UNC, University of North Carolina, who are really experts with children with disabilities. We work together, and so if you have kids with disabilities, really you should search our website, thelearningtrajectories.org, for STEMmy activities. When you're doing patterning, search for those. It'll give you really good ideas on that. So you can, and if anybody has kids and wants to know more, then put it in the chat, and I will try to stop sharing this screen at some point, share the Learning and Teaching with Learning just later, and then we'll do that. So you do children patterns too. Another great activity. All these are on the website. You can often see videos of them, but you can also see a whole PDF of the activities. Here I'm just giving you an overview, but I'm telling you that the details are there. Having kids stand this way and that way. And you might wonder, why is she holding up a V or a number 2? I'll get to that in a minute. There's a thing we call the hand and finger strategy, and it's really effective. And I know it comes up on a slide, so just remember this visual, right? So back to the forest and the trees, their initial understanding, remember? Then work with other core units, then understanding the core unit and its iteration, translating into different materials, and numeric patterning. Okay, so where are we on this? How do we work with other core units, right? So, and then using that. So here comes. Here is the hand-finger strategy. And boy, I shouldn't have taken apart my simple and overly short example here. The hand-finger strategy, not going to come across super well in Zoom, but I hope you can see me here. The hand is the core unit, and the fingers are the element of that core unit. So what we do when we're doing a pattern with kids is we'll say it first with colors here, right? So we'll say, let's say it together. Ready? Orange, red, and orange, red, and orange, red. So what am I doing to emphasize the core unit? Lots of things, right? I'm saying orange, red, and then pausing. Then I'm even saying the word and orange, red, and orange, red. Do you see how different that is from just saying what comes next? You know, orange, red, what comes next? Orange. No, we want them to think orange, red, what comes next? Orange, red. So the other thing that this does so effectively is my hand stands for the core unit, and these stand for the elements. So the important thing and the way I move the hand is to say orange, red, and then I make a big movement back to the next core and the next core. So that really helps make the core more salient for kids, more obvious. And so another thing we do is, for instance, once kids are learning about the core unit, we sit in a small group. You could do it with your whole class if you had enough cubes, but it's pretty tough. And then we decide on a core unit, and then the kids all make their own core unit. If they're done with one, they make two, but they stand them up, because then you can put these core units next to each other and it's clear these are identical, right? And then they all hook them together, right? That's a great thing about connecting cubes. So then you see that this kind of yellow, yellow, white, and yellow, yellow, white, and identifies the core unit. So that's another very powerful activity. So
balls.
Kids do it naturally.
That's a pattern.
That's right, it's a pattern. What kind of pattern is it?
Medium, little, big.
Medium, that's right.
So my comment on here is twofold on that video. Good for that little girl. She didn't identify the pattern as keep going. She identified as medium size, little, big, right? Medium, little, big. And she stopped because she saw that was the unit there. The second observation is the teacher could have done, honestly, so much more than that. Naming it an ABC pattern, asking then what were the next 3 that they needed to extend the pattern and stuff like that. We need to do more with building on kids' understanding and the like. All right, translating to different materials. This is really the structure part of patterns and structure. When you realize that a pattern isn't color, And I'll get back to that too later on in the talk. And you can reconstruct any pattern using different formats and materials. It's very powerful. Let me just turn back down to the chat. Give me a second. Nelson said, I have them make a black stop line at the break between core units when we pattern on our paper calendar. Golden, thank you very much for that. Oh, look at, I even gave you some fireworks here. I didn't even know I was doing that. So excellent, excellent, excellent idea. Separate those out visually then is letting them, scaffolding them into, for sure, recognizing that what is repeating is the core unit. So, hey, they're difficult. Let's face it, patterns done well aren't as easy as they would seem. One new kindergarten teacher struggled, and even ABAB can be difficult, okay? The teacher wanted to teach patterns. This comes from a study in Australia, right? Kindergarten teacher in Australia. And a kindergarten teacher struggled because she just said, bring in clothes that have patterns. And she said, these are great patterns. Okay, there's something going on there, but it's really hard to discern, right? So if you're going to ask kids, and ask their parents, of course, to come in with patterns, you want patterns that are simple enough that kids can abstract the pattern. Even ABAB can be difficult for kids. So letter naming can be useful and accessible after the intuitive patterns are learned. And what I taught kindergarten. I taught preschool for 1 year, and I taught kindergarten for 5. And when the first time I taught kindergarten, I read a wonderful book. This is decades and decades ago, by Mary Beretta Lorton, called Mathematics Their Way. And she said, you know, don't call them colors, call them ABAB. And I thought, that's ridiculous. How are kids going to understand it as ABAB? They're just learning their letters. That's too hard. That's too abstract. So then we did patterns and everything, and I told kids, okay, look, we're going to clap, clap, slap, clap, clap, slap, clap, clap, slap. Can you make that patterns with connecting cubes? And they said no. And I said, yeah, just do this pattern. See, clap, clap, and then a slap. Use the cubes to show me that pattern. And it couldn't, no. I was just so frustrated. I thought, you stink. I'm teaching this so badly. So the next year, I remembered what Mary Burrell Lorton said, and I said, okay, I'll try this. Let's do this together. Clap, clap, slap. Clap, clap, slap. Clap, clap, slap. You know what the kind of pattern is? That's an ABB. 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 Can you make an ABB pattern with cubes? They all picked them up and did it. People, I thought it was too abstract for them. I thought it was too, using terms they didn't know, and how are they going to figure out? It was great. They just learned it right away. We named all patterns AB right from the get-go, and they took off. They could generalize, they could translate it, and the like. And this is just a quick aside to say, there's patterns in different forms too, not just repeating patterns, but of course symmetrical patterns and the other thing. Okay, so just a quick takeoff on a Western. There's a good, there's bad, and there's kind of unfortunate in teaching. The bad first is limitations in practice. Listen, I'll tell this story of myself again. Julie and I, when we start developing our learning trajectories for patterns and our building blocks curricula that featured patterns in this way, we were working with teachers. 35 teachers helped us develop all this stuff. By the way, we always learn from practitioners, and so I don't have enough things that I can show here, but maybe you could see. I can only hold two at a time, but we do a pattern like with toothpicks or something: vertical, vertical, horizontal, vertical, vertical, horizontal. And a teacher in the back just raised her hand and said, "There's no pattern there." And we say, "Okay, I'm sorry, did we mess it up? Let's see, vertical, vertical, horizontal, vertical, vertical, horizontal. Yeah, why do you say there's no pattern?" And she answered, "There's no colors." And we had not realized that through weeks of work with them on patternings, everything we had used to make patterns was colors. Even the famous pattern blocks, you undoubtedly know pattern blocks. We'd make patterns with those, but the teachers didn't say hexagon, square, right? They said yellow, orange, yellow, orange. So one limitation in practice is don't use the same materials all the time, and don't give such a limited array of materials like Julie and I did incorrectly, that people have a limitation of what they think. We've already talked about the next one. What comes next is an okay way to start, but people go into the putting the black separator between your cores and the hand and finger strategy and everything. And then finally, across the early childhood, in its time, have number and algebra. Hey, we even talked about 2 claps, 1 clap. 2 claps, 1 clap. We're already connecting that to rhythmic subitizing and number. Wonderful. I'm going to skip that one, I think. So we said, what is good? Improvements, the variety of materials and representations, emphasizing the core unit, do towers, do questioning, the hand-finger strategy, connecting patterning to number. We have an activity that's build stairs, right? So it's simple growing patterns. That is, kids make a stairs with these connecting cubes, and this is pretty well impossible for me to hold up other than simple. So, 1, 2, 3, 4, and they just build the stairs up to 5, or if they can do it up to 10. That's a growing pattern, but it's really good to get beyond repeating patterns by the end. Okay, I already told that story, so we're done with that. And that's just a good example.
So this time I'm going to do it again. We have just the way you like it. Ball.
Dog.
Dog.
Ball. Dog. That's what I do.
And then
I make it the right way. Dog. I mean basketball.
What's next here?
And dog.
Okay. Now, all right. And here we have some new things. We have frogs. Let me put them in front of you. Okay. Can you sit back a little bit? We have a bunch of frogs. It is a new one, and we have a bunch of, what do you call these?
Birthday hats.
Okay. Now suppose that we start
Yes.
with
Birthday hat.
party hat. What
Can I
comes?
do it all while you're doing it?
Yeah. Can you do it the same way like this? Okay. What comes next?
I mean party hat.
Okay. What comes next?
Fuck.
Okay. What comes next?
Birthday hat.
Can you make it go even more? Even more? Okay, close your eyes, close your eyes. So which one did I take away?
This one.
Yeah, what was it?
Frog.
Oh, how'd you know that? How'd you know?
That's why two birthday hats, why never frog in there?
Oh, 2 birthday hats, and there has to be a frog in
So
there.
lots of interesting
Excellent.
stuff, but I want to start with Julie's comment. Right to left, yeah, I have no idea why Herb. I love Herb. That's Herb Ginsberg video he shared. That you know, I have no idea. I would not have gone right to left, especially when he went the other way. Maybe he was seeing if the child could identify the pattern going in either direction. I just don't know if or if it was just a kind of mistake on his part. It does illustrate at least this. First of all, I want to say another thing critical, as long as Herb isn't here, that the kid is laying the pictures right under them. Again, that's more like picture matching. I think this kid gets it, don't get me wrong, but it's not a good habit. Doing it way down farther and to the side is a way better way to see if kids really understand the patterning concepts. The good thing is the child could extend just fine and even identify, but had a hard time explaining why, and using the ABAB language is a wonderful way, incidentally, to give kids ways to talk about them and answer such questions instead of saying, I don't know. It just fit. There were 2 of the other things in a row or something like that, you know. Finally, I want to say that, again, nothing wrong with this video, nothing wrong with starting with ABAB, but people, you want to stop AB, no, not stop. You want to have other types of patterns than AB as soon as kids possibly can. Otherwise, they get caught in an ABAB rut, which becomes its own limitation. That's all that a pattern is to them. One thing then the other, one thing then the other. So you want to start with it, but proceed. And so there's too many videos where everything is an ABAB pattern. Even our videos, we had too many of those and not enough of the other ones. We can't pair up in what we're doing here. So back to the good. You know, geometric patterns are also really important, even though they're not repeating patterns. So I'm going beyond repeating patterns and that kind of thing. Pattern blocks are really fun to use to make other kind of things. For instance, the challenge here is to make a bigger square from little squares, a bigger rhombus from the pattern block rhombus, a bigger triangle from the pattern block triangle. And these are patterns too. And then see if you can make a bigger hexagon from a smaller hexagon, from the yellow hexagon, you know. Really good challenge to kids that you can't do. So like here, let's see if there's any questions. No more. You're happy to say, I want to hear more about this, less about that. Ask a question anytime. Numeric patterning is where we're going to go to next then. That's a really important transition. So here we go. And this is our website, by the way. I almost want to stop. Ooh. There we go. Back. I almost want to stop and I think I will. If you don't mind, people. There has been a couple of comments, and I'm going to stop share and get another window open. I think I'll show you me signing in here because it might be helpful. So let me bring that over. Sorry, window doesn't want to come over. There it comes. I'll share this window instead. So here's our website. When you first go there, there's a little video of Julie, and Julie's my wife and colleague, at the beginning. And then I love this one actually because this is a video that Nadine made, who's an educator, a teacher, and a doctoral student. And they did learning trajectories use this website in their class, and she loved it so much she made a video on how you use it, so that was fun too. She shared it with us so we could do it. Anyway, this is our website. If you don't know it, I'll just introduce. Right now you would click sign up if you haven't already. I can kind of just click on sign in and do that, so I'll do that real quickly. But you would just sign in. The people, the hundreds and hundreds of parents who gave us permission to put their children's pictures and videos of their children on the website, just asked that we make sure that it was going out to educators who had signed in with their email and everything. So yeah, absolutely. So here we are on the homepage again, but I will click on Explore Learning Trajectories, and down here, these are kind of composed by number and arithmetic and relational thinking, which pattern leads to, geometry and spatial thinking, and measurement and classification and data analysis. So that's all with these rows. This is for birth through grade 3, and we can click on pattern and structure there. And here are the levels we were talking about. So kids can recognize a pattern, kids can do A-B patterns, then patterner. And let me show you what's going on here is this clicking on this information here will define each one for you if you want to do it quickly, right? So you can see what they're about here. But you can also just click on here and you would see the same information here, but you'll also see videos of kids at that level. So here we go. There's a kid.
Look, a piece fell off. What piece is supposed to go?
Rhombus, rhombus, trapezoid. Rhombus, rhombus, trapezoid. Rhombus, 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 trapezoid, rhombus.
Okay, so there, and notice there's 4 videos that show you different aspects of what it means to be at this patterning level. And then we were talking about activities. I can click here, but people, you could just scroll down. That's all you have to do. And then there's all these activities. Here's stringing beads. Here's dancing patterns, which we talked about. Here's pattern strips we talked about, right? So if any of these you click on, pattern strips, you often you can see a classroom video. Not always. COVID killed us on collecting classroom videos just when we were funded to do so. So we're still working to catch up on that. But you can read the activity online if you prefer. But the 2 things I want to point out for sure for you is that if you speak Spanish, you can get a Spanish PD, right? And then you can print out that PDF if you like, or just read it on the screen if that's your pleasure. So every one of these lessons is fully laid out, fully research-based and the like. So we get them from our research, we get them from other people's research, always the best kind of thing. And then don't neglect down here, if there's the materials you're going to have, and if the materials, I wonder if I can find quickly find pattern stringy beads, and if I can get that up here so I can show you, because I assume that when we scroll down, this just isn't a list of activities here. This is pattern tags. So now print them out if you want to. Here's a whole bunch of A-B patterns. Here's some AAB, ABB, AABB, and the like. So there's all the materials we can have that you can print out, and it lists the other materials you would need for the activity. And let me see, I'm going to do one more search for STEMI. This is for children with disabilities that I was telling you before. So, this is searching everything, right? That's okay. That's okay. I'm not going to worry about the patterning activity. This is actually measurement activity and area. But what these have is a lot of suggestions for adaptations for children with various disabilities. Whoops, this is not coming. No, my interpreter. You'd have to download it and see it in a PDF viewer to see it the way it's supposed to show. Let's see if no questions. Oh, Julie has some. Regarding ABC, we take for granted that children know the alphabet right. What if a child doesn't, or is ELL? Has anyone experienced that? I would ask the group this because I don't know. We have always had, even though we've got a lot of Spanish speakers, the ABC thing did not matter, although we tried to do the colors and the object names for sure in both English and Spanish in those classrooms. But generally, they're able to pick that up. The odd thing is that many immigrants come to us, and we think we should use Spanish cognates whenever we can, and we do, but a lot of mathematical terms these kids actually are learning in English in their families rather than in their home languages. So using both has just been really effective for us, Julie, and it's a great question. Great question. Okay. Oh, I wanted to show you a few other things while I'm here, and then we'll go back to patterning per se. There's a whole lot of resources here for teachers, so you can see all kinds of videos of the various things we talk about and everything. There are other resources for inclusion. So here are a good kind of guide to adaptations we developed with UNC, like I told you before. The University of North Carolina experts put all this together. Here's adaptations in materials, adaptations in teaching practices, and things like that. Oh, yeah, preschooler with complex communication needs. There's how you can use those devices and the like. Okay, what else? That's here. I wanted to go back to patterns. I know I'm clicking around a lot. I hope that's okay, people. Oh, there we go. You can also click on Learn About Patterns, and that's going to explain it in text and a short video of me explaining its importance, which we already talked about today. But here's... No, Doug, don't start. Don't start. Don't start. Boring. Okay. This is the part I wanted to show you again. If you need adaptations for children with any disabilities, these are specific to patterning. So those aren't the general ones that were in the resources page. These are specific. How do you make adaptations when you're teaching patterning? That's especially important for kids who have visual disabilities, are blind, for geometry as well as for number and other things like that, and patterning. So what do you do when it's not visual? How do you use rhythmic pattern and give them materials they can feel the differences and create and stuff like that? Those are all for every topic, and again, multiple topics. So we'll return to mine, because we're just about to get to numeric patterning. We started talking about it, and then we're going to talk about these higher levels of relational thinking. That's where patterning goes, towards algebra. You can call it pre-algebra, you can call it early algebra. It's arithmetic patterns. Algebra, especially like in middle school and then high school, is really a generalization of the patterns of arithmetic. And then you take it much farther along the mathematical sphere. But if we can get kids started on that, we have done them massive good. Okay, so now I got to go back to my presentation, share, presentation. There we go. Okay. So, oh no, come on. There we go. Nope. Why is it going over here? Get this window out of there. Click here. Oh, that's funny. Huh. Sorry. It keeps going to my browser window, which I didn't want. So growing patterns. Many of you may know about this. Oh, another comment, Stacy. A lot of my pre-K students don't know the alphabet, but they catch the pattern just by looking at it. For example, my number line is in an AB pattern, turkey, pilgrim, and I just ask them which picture comes next. Absolutely. Stacy, if you don't mind unmuting, do you add the AB language after you've done the picture identification or alongside it so they start to get familiar with that?
I do it alongside it,
Yeah,
but
perfect.
a lot of them don't understand the AB, so that's why I just do a lot of pictures.
Yeah, yeah. And as long as you're introducing the AB, hopefully you're laying a framework for them to get generalized language at one time or another. So that just makes perfect sense. Well said. So growing patterns are like this. You guys might be familiar with them, but I'm just trying to say it's different from repeating patterns because indeed the top stays the same, but the bottom's just growing by one. This one's a little different, right? So this one went from 1 to 3 to, so it starts to, you think about the 1, 2, 4 and all the ways that could go. And then it's just fascinating, right? How is this 3 that now went to 6? Is that going to go to 9? Is it going to, is it, how, why? And so the analyzing these kind of things, analyzing things, triangular numbers like that can get really complex. The patterns there are just outstanding. For instance, you can go this way where you just fill in another on each side to add 3 to each side. But if you build in the whole thing like this, which is what I was planning, what are you doing? You've got one in the middle now, and you've got this. Or you can think of it as when you're making the triangle bigger, it's almost like you're just adding the bottom layer, right? So, wow, that makes sense. 6 goes to, oh, I'm so sorry, I'm clicking rather than pointing. 6 here, you add the bottom layer, it's still a triangle, but you've added 4. Then you have to add 5. Then you have to add 6, right? If you think of it that way. But kids think of it in all different ways. And for them to discuss different ways they see that and the like is just fantastic. It's just so much mathematics comes out of that. Then what else can we do with pattern? For sure, you could lay out a simple pattern like this, a repeating pattern, right? A, B, A, B, triangle, pentagon, triangle, pentagon. But then we could say, so what shape is number 8? Well, everybody knows then. Pentagon. How'd you know? Well, it was an A, B pattern, and that was the B that was missing there, or that was the next one, or whatever. Okay, then you ask, okay, how about 12? What's 12? How do you know, right? So then kids, can you tell me what 20 is without laying them all out or counting up? How would you know? Well, again, we go back to that I said with dancing around 1, 2, 3, 4. All of a sudden that 2, 4, 6, 8 being loud may be working for kids. And they might say, I know 20 is a pentagon because 20 is an even number, or whatever language they use. It ends with a 0 or something like that, So a lot of mathematics going on as long as we extend it in similar ways like that. Then kids become arithmetic patterners, right? So this is where algebraic thinking really starts. First graders can invent several algebraic generalizations about arithmetic. For instance, any number added to 0 is that number, right? And if your kids know their letters and are fine with letters standing for numbers, they could talk about n plus 0 equals n. It's the same. It's the same. It doesn't change it to add 0. Add 3 numbers. It doesn't matter which 2 you add first. So that's a very different kind of algebraic thinking, but it is a relationship. You can add, 2 and 3 to get 5, or you could add 2 and 3 to get 5, and then the 4 to get 9, or you could add the 3 and the 4 to get 7, and then the 2 to get 9. It doesn't matter. And those kind of things, these properties, like I didn't put in here commutativity. If you add 2 numbers, it doesn't matter what order they're added in, right? 3 plus 4 equals 4 plus 3 kind of thing, the commutativity thing. And then this would be, the math name for it is associativity, right? But kids don't have to know those names. In fact, wonderful mathematician Roger Howe, who worked with us for a long time on this kind of stuff, he calls it, with addition, he calls it the any which way principle. So you can add them any which way. It doesn't matter which you add to which or what order you add them in. Any which way works with addition. Not with subtraction, as you guys know, but with addition. So the commutativity, associativity, and the like are not as important as the ideas. The vocabulary, not important, the idea. And then some kids in first grade in the research can pick up these kind of things. If you have 5, you add 2, and then you subtract 2, you're back to that, the identity kind of principles of that. So they're capable of learning pretty powerful ideas, and learning and articulating these things super enhances their arithmetic understanding, right? I mean, this is arithmetic, but we're talking about generalizing arithmetic principles, so they have them in their cognitive toolbox when they're doing mental addition, when they're checking their calculations and stuff. That all provides a solid basis for extending their knowledge to learn algebra.
True or false? True or false? Adriana?
True.
And why is it true?
It's kind of like 9 plus 0 that equals 10, because 98 plus 0 equals 98, because
Yeah.
if you erase the 0, it's like nothing there, and 0 doesn't stand for completely not anything.
What does 0 stand for? I think that we're kind of talking around that circle.
Nothing.
We've got this thing, and what does that stand for?
Nothing.
Nothing. What do you mean nothing? I mean, like,
It doesn't mean you don't add anything.
no, you mean, okay, listen to what Patricia said. Patricia said that if you're adding 0, it's like you don't add anything to the group. What would that be? That's an open now. What could you put in that for that number sentence to make it true? Joseph?
841.
How come?
Because it's for the food. Can I go get some cubes so that's
Okay. Joseph is going to get us some cues. Please do not get 841. Good. Yeah.
And you want to add something else, and the only numbers you know are 10 and 0.
Okay.
And you want to add 0 onto 10. Then you add it on. It's still 10.
So you mean, you gave me 10 blocks right here, 10 cubed. Now if you're going to give me 0 more, give me 0 more. Do you agree with does that make sense?
Yeah.
Ellen, what were you going to say?
Like if you add 0, it's just going to be the same number.
If you add 0 to a number, Ellen says it's just going to be the same number. Is that always going to be true?
Yeah.
It sounds to me like we've got an idea of something that's always going to happen in math, right?
Mm-hmm.
That it's always going to be, I think you guys are agreeing with Ellen that if you add a number, add 0 to any number, it's going to stay the same. And we have a word for that we sometimes use, and that word is conjecture. Because conjecture means that this is something that we think, near as we can figure, is always going to be true. Ellen, can you remember what you told us? What did you say?
If you add 0 to a number.
Okay, we've probably seen enough of that. She's really trying to get the kids to think about that for sure. Ooh, that went a little funky over here. But again, building on these experiences, another thing we want kids to see patterns is, of course, patterns all over the place. So in the simple hundreds chart, write me on the chat if you want to, if you do similar things. But if kids color in, and there's some software that does this automatically for kids if you want to do that kind of thing, but they can just color in every third number and then look at what you see and why is that happening? Why does that happen where you get these diagonal lines? And what's the relationship between these diagonal lines? So 3 to 12, oh, Doug. 6 goes to 15, goes to 24. Why? Right? 69, 78, 87, 96. What's happening there and why? So it's just a fascinating thing. And then doing that, you can picture, I'm sure, that doing all even numbers, you could just see them there, right? Is going to just be row right, white, row yellow, right? How about all 4? How about 5? How about 7s? What's that going to look like and the like? And then again, early algebra also can be functions. So some of these things we've already mentioned are very similar to functions. And functions, the old y equals x plus 3 or something. So what is this function? You can't see it. Sorry, number of tricycles and number of wheels. So it's 1 and 3, 2 and 6. And so now we're talking about, you don't have to use that. And I'm not promoting you use that with kids, but it's just y equals 3x, right? How many tricycles times 3 is the second column there. And then kids can look at those columns and talk about the patterns within each column, the patterns across the column. It's just so great. So we talked about that. Oh, and that leads to the role of equations. A couple people did put it in the chat. What are, Anna, unmute again if you don't mind, and Julie, you next. So get ready to unmute. We have number chart puzzles. So cool, Anna. Just tell us what those are. Can't hear you yet, Anna. Might be a sound problem then. How about you, Julie? Love number charts. How else do you use them?
I used them extensively when I was a classroom teacher. It's been a while. That's been back in the day, but it visualized patterns so well for the second graders that I was teaching at the time.
Yeah, can you tell us anything else you would do with them?
Maybe break them down. Yeah, maybe break them down into smaller charts.
Okay.
But the students, were very successful learning with number charts.
Yeah, another thing, lots of things people do, and if people have other ideas, please put them in the chart. And Anna, just tell me if you can unmute, or if you don't want to. It looks like the number chart, only there are puzzle pieces. Anna, are they? Keep putting it in the chat if you don't want to unmute. But so did you take like a hundredth chart and cut them into parts in various ways? And so it's almost like a jigsaw puzzle, but they're parts of pattern. I've seen teachers do that. I've seen them fill in some numbers on a pattern chart, but no. And you bought it, but is that the idea, Anna? I meant, it was pieces that when assembled, kind of like a tangram puzzle into a tangram, it would make a thing. That's really cool too. Boy, I wonder if I can. Do I have time? I better. Let me finish first, and then I want to show you maneuvers on lattices if we have the time. Okay, we covered that. Oh, again, people, if you are going to use equations, you really want to do more about um, um, so many kids. You people who are experienced teachers know a lot of kids, if they're given 3 plus 4 equals blank plus 5, you'll say, what goes in the blank? They will say 7, because that's what comes after the equal sign. And then you ask them, what does the plus 5 do? I don't know. It shouldn't be there. You know, so if we just get used to saying blank equals 3 plus 4, and then eventually 3 plus 4 equals 5 plus blank, you know, and then 3 plus 4 equals blank plus 5 and all other things, kids get the idea that the equation is a balance, that both sides balance. They mean the same number, they indicate the same number, and that's what we're doing with that. So many worksheets, textbooks, everything's number plus or minus number equals blank, right? And that's what
Kevin,
kids do.
I have a number sentence
But we
here for
want
you.
them to reason with numbers.
And I'd like you to read this number sentence. Here, can you grab that? And then tell me what you have to put in the box to make that work. Could you read that for me first, please?
4 plus 5 is the same as plus 3.
Okay. All right, could you tell us what you'd have to put in the box or the to make that true?
I put 6 in that box.
Wow.
So, that was a lot of work. He wasn't sophisticated in the mathematics there, or was he? For his level of thinking, not only was he happy to kind of put in the work, but you know, he had to quit to tediously figure out how much was it on one side. He could figure out how much do I have to add to make the other side. It took him a long time. Think of this. Think of the reasoning that he's developing, not just the arithmetic or the pre-algebra, but logical reasoning too, along with the pre-algebraic thinking. Also think of executive function, right? Working memory, updating working memory. This task gave that kid a lot of experience, and we know that the executive functions, you know, attentional shifting, updating working memory, response inhibition, these are all developed by tasks that challenge those abilities in kids. And so this was a great task for him, and he did a good job. Whoops. Come on, play. Nope, not going to play for me. Come on. Started and I turned it off somehow. There we go.
So Molly, explain what X is.
So there's this sheet of paper right here.
Uh-huh.
And there's 4 plus x equals 6. 10 minus x equals 5. So I think x is like 10 minus x equals 5 is like the number. So if you have 10 minus x equals 5, it's probably like there's 5 less in 10 minus x equals 5.
So if 10 minus x equals 5, what would x be?
Probably the number,
Like what? So if 10 minus x is 5, what's x?
the number.
Which is what?
What number? With 10, you have to go down 5 and it's still 5.
Okay. What about this one here, where it's 4 plus x equals 6? If you have 4 plus x equals 6, what would x be?
Two.
Why?
Well, 2 more numbers.
Why?
Because 4 equals 6. 4 plus 2 equals 6.
Good.
So I
Can you make a problem with...
I kind of liked the other boys, or whatever he said, better than just slipping in x. That satisfies us as adults. Oh, x is a variable name for that. But, you know, the kids thinking the hoop is just fine. I think
And I'm
we're
going to ask you what number
pretty
goes in
close
that
out of
box?
time. Let me see how long
And
this
then ask you
is.
how you know.
All right, we may be able to do
David?
one more.
5.
5. Why do you think it's 5, David?
Well, it's really, if it's 6 plus 2 there, and there's a 3 there, it would be just, I couldn't decide between 5 and 7.
Oh, okay.
3 was 3 was 1 more than 2.
Uh-huh.
And 5 was 1 less than 6. Instead of doing the same way in my head, how it was there, 6 plus 2, which would be 6, 7, 8. And then 5 plus 3, 5, 6, 7, 8. And then I just to make sure, I double checked. And it was the same.
This kid's like
38.
I gotta quit, but that kid's just a dream. Then I just checked at the end. Come on. How many kids want to check their work ever? But that was I love that because his first reasoning was, wow, 2 is within 1 of 3, so the other number on the right hand side should either be 5 or 7, but I gotta think, do I go up or down? Because I have to compensate for 2 being less than 3, so I have to have this one be less than, and he thought about that, and then he did the addition to make sure 8 was on both sides, and then he said he checked his work again by adding up. So an exceptional kid probably, but just wonderful. And so I'm the big story, of course, is number relations, like what shape is number 20, up to these algebraic add 0 to any number, it's still that number, up to the compensation idea and the balance idea of equations are where patterning goes. But if you're doing AB patterns and ABC patterns, and you do them with the core unit, and then you go to growing patterns, you are building the foundations for that. And we are out of time, and I hope I got some useful ideas out there. Thank you for the people that talked, and thank you for the people that put things in the chat. And it's back to you, Karen.